Hello, this is from Vijayakumar, Assistant Professor, Department of Physics, SNS College of Engineering. Today I am taking that the crystal physics topic. The topic is Miller indices and interplanar distance. So, how do you find the Miller indices of a plane, and why do we use Miller indices, and how do you calculate lattice spaces? So, this all is a question we discussed about this topic after we get the answer from this. First of all, what is Miller indices means? The Miller indices from in a notation system in a crystallography for planes in lattice manner. This is a 3 plane integers for an example of HKL, that is called as a Miller indices. It's a form of simple cubic crystal structure. So the lattice constant to the form of simple cubic is a and the space is D. So this is a 3-dimensional structure to the form of cubical in a Miller indices. So the Miller indices form to 1, 0, 0 is the opposite of x and y. Then 0, 1, 0 it's the opposite of y. So it's a form of 9 formation, and the inverse also to be added from this diagram. So this is the assignment we given from in our student to find from the Miller indices values to based on this picture. The next topic we discuss from this PPT is an interplanar distance. The interplanar spacing, it becomes separation between set of parallel planes formed by an individual cell in a lattice structure depend on the radii of atom forming the structure and shape of a structure. So we get the value from distance of in a 2 lattice plane to finding out this formula to based on the Miller indices wise. So the distance D HKL is a Miller indices is equal to A is a lattice constant divided by root of h squared plus L squared plus K squared. So this is a final formula to finding from interplanar distance. So this formula we have derived from based on the diagram, the cos values of alpha, beta, gamma, that is in a angles, interplanar angle to based on in a Miller indices. So we get the ratio of cos squared alpha, cos squared beta and cos squared gamma. This value in mathematical steps wise is equal to 1. So the finally we get that the D is equal to 2A divided by root of h squared plus k squared plus L squared. So based on this formula we have find the interplanar distance in between of 2 lattice to arrangement of atoms to occupy of a different formation in a crystallographic structure, and also we get the interplanar angles alpha, beta, gamma based we have find from in the Miller indices. So the Miller indices is a very important role to finding of that crystallographic axis and angles. So the first question, how do you find the Miller indices of in a plane? So we get that the value of Miller indices 0, so that the axis becomes as not interconnected. The value of 1 it becomes a connected. Then the reverse it becomes an opposite. So why do we use the Miller indices? Because the Miller indices is a basic property to finding out the crystallographic structure. After that we have get from the interplanar distance. And how do you calculate the lattice spacing? That means interplanar spacing. That is a formula we find from the D is equal to A divided by root of H squared plus L squared plus K squared. So we get this 3 question answer from this PPT. So this is all the reference I prepared from this PPT. Thank you very much. We discussed the another one video in another one topic.